Good morning to all. I am G.A. Hegde, working as Associate Professor, Department of Chemistry, KGF First Aid College, Urgam, KGS. Today, we shall discuss about third session of Inorganic Polymers. This chapter is included for third semester BSc, Bangalore North University. Under this, we shall discuss fibers, rubbers, fluorocarbons, silicones, etc. Under this, we will discuss about preparation of these type of polymers, monomers and their partial structures, applications of these type of polymers. After studying this, you will understand about the various types of polymers, the preparation of these type of polymers, the applications of the polymers, and also their structures. In order to understand this, you must have the knowledge of fiber, rubber, etc., and also synthetic polymers, and also the knowledge of the silicones. With this, let us discuss about the fibers. Fiber, these are the polymers which are made up of narrow molecules. They are strong and flexible. For example, silk, wool, cotton, cellulose, etc. Second one, acrylic fibers. It is formed by the addition polymerization of acrylonitrile. N number of acrylonitrile reacts to form polyacrylonitrile. Uses of this, it is used in blankets, carpets, etc. Third one, polyamides. Nylon 66 is prepared by the condensation of adipic acid with hexamethylene diamine. When one molecule of adipic acid reacts with one molecule of hexamethylene diamine, it forms one molecule of nylon 66. Large number of this nylon 66 undergoes polymerization to form polymer nylon 66. This is called nylon 66 because one molecule of adipic acid and one molecule of hexamethylene diamine, they contain 6 carbon atoms each. Uses, it is used in textiles, bearings, gears, ropes, toothbrush bristles, etc. The next one is polyester. It is prepared by the polymerization of dimethyl terephthalate with ethylene glycol. When N number of this dimethyl terephthalate reacts with N number of ethylene glycol, forms the polyester, a polymer. It can be blended with varying amounts of cotton, wool, etc. Uses, it is used in textiles, wires, ropes, toothbrush bristles, audio video tapes, etc. The next one is nylon. The nylon is prepared by the polymerization of caprolactam at 550 Kelvin under pressure. Large number of caprolactam undergoes polymerization to form nylon 6, a polymer. This is called nylon 6 because one molecule of caprolactam contains 6 carbon atoms. Uses, used in textiles, wires, ropes, toothbrush bristles, etc. The next is rubber. There are two types. One is natural rubber Another one is synthetic rubber. The natural rubber, it is naturally occurring polymer of cis-isoprene having the composition C5H8. N number of isoprene undergoes polymerization to form the natural rubber. The naturally occurring rubber is soft and sticky, having low melting point and elasticity. It does not find much commercial applications. In order to make more useful, the natural rubber is subjected to vulcanization. It is the process in which natural rubber is heated with 3 to 5% sulfur at 380 to 400 Kelvin in presence of zinc sulfate catalyst in order to make hard and more elastic. The vulcanized rubber is hard and retain elasticity over wide range of temperature. It has good tensile strength and resistant to wear and tear. It can be molded to desired shape and size. The rubber containing more than 32% sulfur is known as ebonite. The vulcanized rubber is used in making tires, tubes, etc. The second one is synthetic rubber. It's also known as Buna-S. It is prepared by the polymerization of 1,3-butadiene with styrene at 320 Kelvin in presence of potassium persulfate. N number of butadiene undergoes polymerization with N number of styrene to form a polymer Buna-S. It is used in making tires, tubes, etc. The next is neoprene. It is prepared by the polymerization of chloroprene at 325 Kelvin in presence of ammonium persulfate catalyst. N number of chloroprene undergoes polymerization to neoprene. It is resistant to chemicals, temperature, oils, etc. and it is non-combustible. It is used in making gaskets, hose pipes, etc. Freons are archotons. The chlorofluorocarbons are known as freons or archotons. Under that, the first one is Teflon. It is prepared by the polymerization of tetrafluoroethylene at 330 Kelvin under pressure. N number of tetrafluoroethylene undergoes polymerization under pressure in presence of benzyl peroxide catalyst to polytetrafluoroethylene, commercially known as Teflon. It has high chemical and thermal stability. It is resistant to heat and chemicals, good electrical insulator and water repellent. Uses: surface material for domestic utensils, razor blades, etc. The next one is silicones. These are the groups of organosilicon polymer or siloxanes. These can be obtained as fluids, liquids, resins, etc. They have network of alternate silicon and oxygen atoms with various groups attached to silicon. For example, R3SiCl, R2SiCl2, RSiCl3. Preparation of silicones. The hydrolysis of organosilicon chloride gives hydroxo compounds which undergoes polymerization to form silicones. For example, R2SiCl2 on hydrolysis followed by polymerization forms the silicon polymer. The equation is R2SiCl2 plus 2H2O gives rise to R2SiOH twice, which undergoes polymerization to silicon polymer. The polymer at its both the ends contains hydroxyl groups. The further polymerization may take place at these ends. Such molecules are known as chain building units. Similarly, when RSiCl3 on hydrolysis followed by polymerization form the complex cross-linked silicon polymer, and this is the equation. When R3SiCl is hydrolyzed followed by polymerization forms the polymer which does not contain hydroxyl groups. Further polymerization is not possible. This is known as chain blocking unit, and this is the equation. Uses of silicon polymers. These are used as electrical insulators, water repellents, anti-froth for cooking oils, high temperature baths, lubricants, etc. And also the silicone gums are high polymers used as lubricants, anti-foams, textile finishing, etc. Silicone resins are high cross-linked polymers, thermally stable and used as non-stick coating for pans, printed circuit boards, mold for tires, etc. After studying this, you just recall what we discussed in this. We have discussed about preparation and applications of different types of fibers, processing of natural rubber and its applications, synthesis and applications of synthetic rubbers, preparation and applications of different types of fluorocarbons, preparation and applications of different types of silicones. With this, let us try to answer some simple questions. The first question is, Teflon is, the answer is B, fluorocarbon. The second one is, the monomer in natural rubber is, the answer is A, isoprene. The third is, the polyesters are used as, the answer is A, textile fabric. The fourth one, the monomers used in Bunai are, the answer is C, butadiene and styrene. The last one, the polymer used in non-stick cooking wares are silicone resins. To prepare this, I have used these textbooks and also internet. For further information, you can also refer these textbooks and internet. Thank you.